And so now we have one more, and this one is fairly subtle, but remember we just did this definition, which is that it's X is either a superkey or Y is a prime attribute, right? That was the third normal form definition I just gave you. And Boyce Codd normal form takes that a step further. It says that for all the functional dependencies, X must be a superkey. Okay. So basically it says you can't, basically it disallows this condition, all right? It can only be X, that X is a superkey. So it's stricter. And remember, all these normal forms are essentially tighter and tighter constraints on the relations. So they're subsets of each other, if you will. And so in other words, it always has to be that it's already in third normal form, but then it has to go further to make it into Boyce Codd normal form. Okay, so let's look at this a little more closely, what Boyce Codd normal form means. And so I'm going to just do this with an abstract example here, where we have a relation R with 3 attributes, and A, B, and C. And there is, what we want to do is find a case where this is in third normal form, but not in Boyce Codd normal form. And so these are conditions I'm going to impose, namely that AB determines C. Now this should be obvious from inspection, right? Because because it's a primary key from here, AB determines C. So that's clear. This one is that A does not determine C. Okay, so A alone cannot determine C. So do you see why? Because otherwise it would not be in third normal form, right? If A determines C, you would have what? What is the name for that? What kind of dependency? Anyone? And in fact, I'm wrong about this. This is not right. This should be not in second normal form. Okay, that's actually that it's saying that if A determines C, it would not be in second normal form. What's the dependency there that would have been the case?
Partial dependency.
Exactly. Thank you, Justin. So partial dependency. So what that means is that if A determines C, I'd have a partial dependency. It would be C would be partially dependent on the primary key. So that would violate second normal form. So I couldn't be so I want it to be in third normal form, but not in Boyce Codd normal form. That's what I'm trying to get. Okay. Next one is that B cannot be in C, and that's the same way. Otherwise, this is also 2NF. Okay. And then this one, C determines B. Okay. C determines B up here. All right. Now I'm asserting that is a functional dependency, and it's a case where C is not a superkey, but it's determining something else. Okay, so that's violating Boyce Codd normal form. And C is not a superkey. If C also determined A, then C would be a superkey, and then it would be back into Boyce Codd normal form. So you see, there's some subtlety here into this is just this is in a way a minimal example that shows you how to get yourself into third normal form, but not into Boyce Codd normal form. And it helps you understanding all these nuances. Okay, so let's go on, and you can study this again later and look at it some more. But basically, we can normalize this this relation and make it into Boyce Codd normal form. And what we're going to do is we're going to take it and create R1, which is going to be A, C, and R2, which is going to be C, B. All right, and this I want to claim is in Boyce-Codd normal form, CB. Okay, because notice that I have, in this case, I have the second one, R2, in R2, I have, I've basically been able to accept all these things up above, but B does not determine C. Remember, that's from the third one up here, but C determines B, so that's okay. And so in all these cases, whenever I have a functional dependency, the thing on the left-hand side is a primary key. Okay. All right. So that's
Professor?
the strictest form that we've encountered. Yes.
Wait, but didn't A not determine C? Like, how does that work in the first relation?
Right. Okay, that's a good point. That A does not determine C. But here we've actually forced it to do. Oh no, I'm sorry. Thank you. Actually, it's a really good point. You are absolutely. Who said that, by the way?
Parker.
Parker. Bonus for you, because you're right. What I missed was that this is the case. Okay, that the primary key for the first one is both of them. Very good, Parker. I will give you a gold star for that. That was a very subtle catch, but you're absolutely right. That was a really, really good point. Does everyone see what Parker pointed out? He said that, I'll erase what I wrote. He said here, he noticed that I had written it this way, and he said, but how can you say that's true when you right up here had said that A does not determine C? And I looked down at that and I got a little hair on the back of my neck stood up, because I was like, uh-oh, I don't know how to explain that, right? Because he's right. This right here implies that A determines C, right? And here we have that A does not determine C. So what is going on? But it was my mistake because I wrote it down wrong. And this is the case, okay? It's meant to be like that. Okay, so that the first relation captures the fact that A and C are both connected, but it doesn't imply that A determines C. Good. All right. Good work. Okay. So now
can you explain that one more time? Sorry.
No, it's okay. It's subtle. And so what happened is I'm going to go back again. So here, if I have A, like if I had written that, which I wrote before, right? Do you see why that implies that A determines C, right?
Yeah.
Okay. But here, right here, I have to say that A does not determine C. Okay, so I have a contradiction that Parker spotted. Okay, but I'm going to fix that because what I want to do is have both of these be underlined.
Okay.
All right.
Okay.
And that makes it consistent. Okay. Okay, so let's look at another example. Remember we talked about this one about student major and advisor. So here I have very analogous situation. I have student ID, major, and then the advisor. Now I notice that you can have more than one major, right? And you have an advisor for each major, but advisors only advise in one major. So that means that this is true, okay? Advisors only advise in one major, right? So that means that the advisor determines the major. Got it, everyone? So this thing right here, it's in third normal form, okay? But it's not in Boyce-Codd normal form because advisor is not a superkey. All right, so we have to do the same thing. What we're going to do is something very similar, where we're going to create student advisor. And actually, we can make this student advisors. student ID, major, like that. And then advisor, major. Okay. Now that gets us into, so this is now in Boyce Codd normal form, okay? Whereas this is not in Boyce Codd normal form. All right, now notice carefully that there is a nuance here. When I do this normalization in this case, what I've done is I've essentially lost what is the exact advisor for each student. Do you see that? Because I now say what major a student's in, and they could have more than one major. And I know that which advisors go with which majors, but I don't know what precise advisor is that student has. Okay, so I've lost a little bit of information in this normalization process. So the moral of this is that you don't always want to do normalization. The normalization has its benefits, but it also can be overzealous. And so you want to apply it carefully. So sometimes you might end up looking at this here and saying, it's in third normal form, it's not in Boyce Codd normal form, but I like to keep it the way it is. And that will be perfectly fine, as long as you know what you're doing. So you say, it actually makes sense. I could normalize it into Boyce Codd normal form, but I'm choosing not to do so. So again, that's your decision. And my goal here is that you make that decision explicitly, and you say, you can spot it. And when you're looking over your database and you say, no, let's leave that because I like to keep that information together, right? Okay.